Hello, this is lecture 8, the second part on online learning and the tool called Vowpal Wabbit, this funny name. So we'll first recap how we apply online learning, and so how it's actually possible to train simple models with actually a lot of data. So in this lecture, I will literally train a model with several gigabytes of data in just some 30 seconds. So just doing live coding. And we'll quickly discuss how it's possible. So we'll recap the idea of online learning from the previous lecture. And we'll quickly discuss hashing, which helps in dealing with data with a lot of features. And then we'll work with StackOverflow questions, so classifying them into different categories, and then we'll do actual live coding with Vowpal Wabbit. So a small recap of online learning. So suppose we've got a huge data set. I will just call it, for instance, one terabyte. So let's say we've got 1 terabyte of data. The idea of online learning is that we don't need to load all of these into our memory. So suppose we've got a small computer with some, let's say, really small amount of memory. So today 8 gigabytes is not a lot. So we've got this RAM. And the problem is that we cannot load all of the data set into our RAM. So let's say these are our Stack Overflow questions, and we've got some text, and let's say we've got some labels. So in our example, these labels will be programming languages like Python, Java, and C++, and we'll have questions about Python, about C++. So we'll have classification of these texts questions into some categories. Okay, so the idea of online learning is that we actually we can store only some vector of coefficients w, and we can read data in small batches. So in extreme case, just one example after another, one by one. So we just read a small chunk of data into RAM. So here into RAM. So we've got some X and we've got some labels Y. And we update model parameters only with these labels. So if this is vector W0, then after that we'll have vector W1. So it will be updated. And we've actually seen how it's done in the previous lecture, so stochastic gradient descent. So please revise the first part first. But here we'll do a step towards anti-gradient with respect to some loss, so some classification loss in our case. So we'll estimate this anti-gradient with the data that we've got with this mini batch. So we'll estimate it with X and Y, and we'll do a small weight update. So just based on a small in extreme with just one example. In practice, we'll do mini batches here. Maybe this small introduction is too short, but recall, so this is covered in lecture 8, part 1. And it's actually stochastic gradient descent, typically called SGD, stochastic gradient descent. So I'm not going deep into this exact formula, but the whole idea is that we only store parameters, and we update these parameters with our data, which comes one by one. So ideally, we only need to have large enough RAM to store this small example, this vector of targets, and this vector of coefficients, W. So it's ideally in theory. In practice, we also need some cache files, some hashing needs to be done, so we need to keep a dictionary and so on. But still, the idea is that we don't need to load all these terabytes. We can end up with much less, much smaller memory consumption. So this can be done with sklearn SGD classifier, but I'll show you the tool called Vowpal Wabbit. So yeah, funny name. I've seen somewhere that it goes back to Lewis Carroll and Alice in the Wonderland. So this Wabbit is actually misspelled rabbit. Vowpal, I don't know what it is, but it's actually a nice C++ implementation of this approach. And I will show you how to use this as a command line utility, and I will also show quickly the Python interface. I will start coding, and at the same time maybe I'll get back to this screen to do some clarifications to illustrate some ideas from Vowpal Wabbit. So we've got some impressive 10 gigabytes of data, and they're classified into 10 classes. So let's first show the data. Here we've got some TSV files, and you see it's pretty impressive. So we've got 7.5 billion, sorry, not billion, million questions in the training set, and 2.5 million questions in the test set. So with some Linux utils, we can actually measure the size of these files. And it's 7.7 gigabytes in the training part and 2.6 gigabytes in the test part. So I actually thought about competition with this data. So I will leave this test file alone, so we're not working with it. But we'll work with this 7.7 gigabyte training set. And it's a bit pre-processed. I've already prepared files in Vowpal Wabbit format. So let's see. So we've got train and validation part in Vowpal Wabbit format, which I'm going to show. And again, let's calculate the number of lines in these files. So these Linux utils like sorry, some Russian here. So VWC will count the number of lines, and we're going to do it for all files with this format VW in this folder. So this will take a while, just a bit. Okay, so we've got almost a bit more than 2 million lines in the training file, and a bit more than 1 million lines in the validation part. So these Linux utils like word count are very handy. They are very optimized, so I really encourage you to get to know these utils. Some of them are actually used in assignment on Vowpal Wabbit, assignment 5. So these Linux utils are highly optimized, so it took humanity some 40 or 50 years to optimize such utilities like word count, and they're really handy, so I encourage you to go through some tutorials on how to use actually Bash and these utils. All right, let's take a look at a couple of lines in these files. Here comes Vowpal Wabbit, so it puts a little bit of requirements on data structure, but we'll see that it's pretty handy. So actually, we've got some question, and I've already pre-processed it for Vowpal Wabbit. So this question is class 1, and I've defined classes there in the beginning. So we've got questions about JavaScript, Java, Python, and so on till Swift. So some 10 classes. So I'll make a comment that these are pre-processed. I'm not sharing pre-processing script, so you can practice a bit in this assignment. So an optional assignment that you can do. So you can practice with Python pre-processing, and you can see how it can be easily done. So I've taken the first question, and to pass it to Vowpal Wabbit, I don't need objects like sklearn, all the different encoders, one-hot encoders, or what we typically do with text, TF-ADF, or count vectorizer. In this case, with such large data sets, that will take forever. Right? So here, to pass it to Vowpal Wabbit, I just copy the whole text. I don't do a lot of preprocessing, so I'm just copying this question. And to prepare a labeled dataset, I just need to pass here a label from 1 to 10 in my case. So preprocessing involved just picking these labels, JavaScript and so on till Swift, and enumerating them from 1 to 10. And so this labeled text is actually about JavaScript, and the next one is about Ruby. Well, for us, for humans, it's sometimes obvious. Yeah, so we see here Ruby in the question text, and it's actually about Ruby, but it's not the case. The question might be about Python versus Java, blah blah blah, and so here it's not obvious how it shall be labeled. Maybe it's a question about Python, but it can also contain words, so some other words. So it can also contain Java and C++ and so on. So at this point, we see that Vowpal Wabbit can easily handle text data. So we just literally pass the same text, and we only need to separate the label from the actual text with just this vertical bar. So really easy. In this live coding, we'll work with text. So I'm not providing a lot of details on Vowpal Wabbit format. So this all can be done in our article. So this topic 8 on Stochastic Gradient Descent and Vowpal Wabbit. And there's a lot about Stochastic Gradient Descent here, and what I'm looking for right now is this Vowpal Wabbit format. So it's all covered here. We'll cover some arguments of Vowpal Wabbit here. And the format that Vowpal Wabbit expects is explained here. So you first pass a label. You can put in some importance weight on labels. So by default it's 1, but some classes can have higher importance than others. And then you can have several namespaces with different features. So in case of numeric features, you just pass numeric features here with some values. So in case of text, these features will be just raw text. So we are using here the simplest form. And it's basically done. The same is done in these examples with text classification. But you can also you can pass not only pure text, but usual numeric features with their values. So we're not covering it here, but it's also easy to handle numeric data. Okay, so this we can already pass to Vowpal Wabbit. And now I'll launch training of the first model, and I will also be commenting on Vowpal Wabbit parameters. Okay, so here I installed Vowpal Wabbit. Let's check version. So Vowpal Wabbit is a bit challenging to install on Windows, on Mac. By the way, on Mac I installed it easily with brew. So for Mac is just brew install Vowpal Wabbit. For Linux it will be sudo apt-get install Vowpal Wabbit. For Windows, I'm not sure, there are some exe files out there, but we all in mlcourse.ai we provide a Docker container, and there you've got Vowpal Wabbit and all the necessary things. So if you go to prerequisites, there is a chapter on Docker, and there are all these instructions how to launch a Docker container. And actually I will be using it today because I failed to install Python wrapper with Mac. Yeah, so this is a console utility, so it's very efficient. You can train really fast. So this VW is console util Vowpal Wabbit, but we'll also need a Python wrapper. So actually I'll be using it from our Docker container that we provide here. All right, so we can run help, and it will explain a lot. So Vowpal Wabbit can do a lot of things. So we are covering the very basic thing, classification. So it starts with some number of bits, so that's we are going to discuss. And then purely things concerning optimization, so stochastic gradient descent. So learning rate will influence classification quality pretty much. And these parameters of optimization, so there's some cool, awesome Vowpal Wabbit list in the Vowpal Wabbit repository with all the nice resources, yeah, including one of my tutorials as well. So this Vowpal Wabbit tutorial for the uninitiated, it also covers pretty well the whole material, so I didn't copy content from there. But there are some details on optimization here as well. So the default procedure is a bit modified stochastic gradient descent with decay in learning rate. So actually, learning rate decreases with number of iterations according to this formula. And you can actually specify this learning rate decay, and these initial parameters, this T and P, this will actually govern the process of learning rate decay. So we discussed it last time, so it's better to decrease learning rate with your iterations, so thus you'll find your local optimum better, more accurately, and keeping learning rate constant is not the best practice. So there are a lot of learning rate schedules that they use currently with neural networks. So here in Vowpal Wabbit they actually implement this polynomial decay. And these hyperparameters actually influence classification quality pretty much. So of course, I'm not going to through all this help. So I will only comment some of the arguments. So actually, the biggest part about so maybe one of the biggest features of Vowpal Wabbit is actually hashing. So feature hashing is an important concept, and here it's, well, this help starts with some number of bits, by default 18. So it's good to explain it here. Actually, when we've got texts, we can end up with a lot of dimensions. Yep, so if we have, like in our case, okay, we've split it into let's say we've got 3 gigabytes of pure text, so text questions. So vocabulary size can be pretty large. Well, I didn't measure it in this case, but it can be easily something like 10 million tokens. So if you just index all of your words, you can end up with such large feature dimension. Yep. So, and in case of n-grams, if you add bigrams, trigrams, you can easily end up with such some feature dimensions about billions. So if you try to train a simple linear regression or logistic regression in case of classification with such high dimensions, well, it won't work. Yep. So you need memory to store all of that. So with such large dimensions, it basically just wouldn't work. The idea of hashing is basically taking a hash function. So we'll have some phrase. Let's say, what's the best language? Well, programming language, but let it be just language. For data science. And we'll so for each word, we'll basically take a hash. Well, a hash function in Python, it will output some large integer. So some examples are also covered in the articles. So a hash function I'm not going deep into these details. I'm basically not really good in cryptography. But what you need to know here about hash functions is that they will output, so based on a string with some string input, they will output some large integer. The most important part here is that we taking this integer, we cannot invert the hash function, so we cannot know the input based on the output. And if we change the input just a bit, the output will change dramatically. So here we use hashing to actually limit our dimensions. Yep. So here we'll end up with some large integer, and then we'll just limit our dimensions. Let's say our maximal dimension will be 2 to the power of 18. So like by default in Vowpal Wabbit. So it's approximately 260k dimensions. So then we'll just divide by this number, and we'll take the remainder. So then we'll end up with a number from 0 to 2 to the power of 18. So basically we'll have some index for the word what, then for the word is, then for the word there, and so on. For every word, we'll have some new feature index from 0 to 2 to the power 18 minus 1. Well, of course, no miracles. Here we'll have some hash collisions. So let's say the word what is mapped to the number 1892. But then there is some small chance that the word language can also map to the same number. So we'll have some hash collisions. So again, it's a bit better explained in the article. But the idea is that these hash collisions are not really very important for us. So they wouldn't hurt accuracy, so classification or regression performance very much. So these collisions are unavoidable. But it's still not a big problem. So it also might occur then that we'll have different words in different examples, and so it can turn out. So it can happen that some word in some sentence will collide. So its hash will collide with another word of a question of a different question, and it's actually, so it's not a big deal. So with large enough dimensions, so the probability of collision is not that high, and even if it happens, it turns out it doesn't hurt classification performance very much. And it's all really well covered in this article. Don't be tricked by hashing trick. So it's by booking.com, and it's really it's a good analysis of how collisions affect classification performance. So in this graph, x-axis is the percent of collisions, and this red curve is log loss. So when we don't have collisions, we've got some small log loss, and we see that when the number of collision increases, the log loss is hurt a bit, but not awfully. So even when we've got 50% of collisions, still log loss is not affected very much. So this paper goes into really nice analysis of collisions and all these dependencies between feature space dimension, also hash space dimension. But the thing to understand here is that this parameter, 18 in this case, so this number of bits, so this number 18, it's in Vowpal Wabbit, it's parameter number of bits. So the larger this number, the more memory we need to reserve to Vowpal Wabbit to store all these features, and the lower is the percentage of collisions. So accuracy will increase with this number of bits, well, but at the same time you'll use more memory. And it's important to understand that your memory consumption grows exponentially. So if you change from 19, let's say, to 20, your memory consumption is going to grow approximately twice. So some realistic numbers are from 18 to something like 29, or well, of course, depends on your machine. But this number of bits is typically in between 18 and, let's say, 30. And so you'll map all your unique words on all the unique bigrams. You'll map to this to some index in between this number. So you are actually limiting the feature space size. All right. Okay, so to train the first model, we'll just call Vowpal Wabbit. With argument d, we'll need to pass to make to actually put a path to our training set. So in this case, it's StackOverflow train .vw, and we one sec. Did not intend to launch it right now. And with flag -f, we'll actually save the model. So the model will also be, so it will be some binary file. Let's just call it model, and by default it will have the same VW extension. All right, so this will train the model. By default it's a regressor. So again, I will stop this one. I would like to do multi-class classification, and the final thing that I need here is to say that it's a classification, and we'll use one against all approach. So this flag OAA, we will tell Vowpal Wabbit that we need to train actually 10 models, one versus all. Okay, okay. Now it's more readable. Okay, so it will be 10 class classification with this training dataset, and we'll save the model here. Okay, so something wrong. Probably two dashes here. Okay, so now we've launched the training, and the final piece that I will add is tracking time. It's a bit boring to wait for something without understanding what's happening. So Vowpal Wabbit shows us some information while training. So by default, it needs 18 bits. So the dimension is 2 to the power of 18. So this approximately 250,000 features. These are default parameters for training. So we don't use cache files. So we are actually training in single epoch. So the model will see each example only once. This can be tuned, so we can do several passes over the dataset. And you see, actually, the model is already trained. Yeah, so it took just 28 seconds to train a model. So it's pretty impressive. But let's analyze what it also prints here. So some log is actually it reports how many examples it has seen so far. So it's powers of 2. It for some reason it prints current label and current prediction. I don't know whether it's really useful. And it actually shows the current length, so the current number of features. So questions actually differ in length, and it also shows this length, and it prints our average loss. So by default, it's quadratic loss. It can be tweaked here. You can change to logistic loss, but actually quadratic loss also works here. And so in the end, it says that it has passed more than 2 million examples. It prints the average loss and the total number of features that it has seen. Actually not useful, I guess. And so the model is trained in 28 seconds. So now we can actually make predictions. We use more or less the same syntax, and the hardest part is actually to remember all these flags. So we'll call Vowpal Wabbit with some different flags, with -e. So now to make prediction, so I'll make a command here. So this will be prediction for the validation set. And now with flag -e, we'll pass the model. With flag -d, we'll pass again the data. So it will be now validation data. So this StackOverflow validation. Let me check. Yeah, StackOverflow valid .vw. And we need to write predictions to some file, and so with flag -p we'll save actual predictions. So this will be validation prediction, just a txt file. Okay, so it doesn't see, sorry, a typo. StackOverflow. Okay. The funny part is actually that training a model is not much more time-consuming than actually making predictions. Yeah. So here we've trained our model just while reading data, and all these coefficients updates, they don't actually take a lot of time, and so we'll see that making predictions for the validation set will take more or less the same time. Okay, 20 seconds, and here we've passed more than 1 million examples. Okay, so now we have this file with predictions. This file, txt file. Okay, and as you see, just a simple txt file with predicted labels. Of course, you can do you can output predicted probabilities. It will be a separate flag, but for now, let's just do raw predictions. Let me check. So here we also have answers for the validation set. So let's see what txt files we've got. Okay, and actually store the correct answers. And now we'll calculate accuracy just with sklearn as usual. So we'll read data with NumPy, and then we'll calculate sklearn metrics. Sorry, accuracy score. Okay, so we'll have y valid. This will be answers. Just np load txt. We've got this path to data, and then this, and we have validation predictions. The same, but we change the path. And okay. Actually, it's funny. We've trained the model in 28 seconds, but then we need something like, let's measure, several seconds actually to load predictions and the actual labels. So with NumPy at least it will take okay, some 7 seconds. Okay, so the training was really fast. And in the end we got accuracy score. Let's check. Okay, it's 87%. It's not that bad, yeah. So well, at least we need to know what the baseline is, so we can take the distribution of these labels, and with np bin count, when we can actually see the distribution. Cannot cast array to. Okay, it's read as float. We can specify here as type int. Okay, you see we don't have zeros, so Vowpal Wabbit expects labels to start from 1, so it's an important notion. So we've got 0, 0 zeros, But then we've got that many ones. So these are about JavaScript, then Java, and so on. So you see the distribution. We can actually see, we can calculate the proportion of the most frequent class. Maybe, yeah, in this case, looks like it's Java. But you see, doing 87%, so having 87% classification accuracy looks pretty impressive with such target distribution. We can draw a confusion matrix as well. So I'll have a small cheat sheet here, some code to nicely plot confusion matrix. I'll just copy paste it here, and we'll plot confusion matrix passing actual labels, predicted labels, and class names. And we need to import confusion matrix. Okay, it also takes a while to build a confusion matrix, and we see we are doing actually a pretty decent job. So predicted labels, correct targets, and well, we can analyze confusion metrics, but it doesn't look really interesting. So there are no clusters of classes that we confuse very often. So even the model even doesn't confuse Java and JavaScript too often, or C# and C++. So predictions look really good. And now I'll also show you some more capabilities of Vowpal Wabbit model. So first of all, we can easily add n-grams. So just with the same code, we'll now add n-grams. Just one more flag, adding n-grams. And we'll also increase the hash space dimension, hash space dim. It's actually argument this number of bits. So this all can be done with just more flags. So we'll increase the hash space very much actually. So going from 18 to 26, it's well, exponential scales. 2 to the power of 26 would be, you see, more than 6, well, almost, how many? Oh, almost 70 million dimensions. So it's, but still it will take a bit, maybe 2 minutes or so. Well, in order not to wait too long, let's keep it at least 22, I guess. And we'll add n-grams. So just passing one more flag, n-grams 2, the model will start building bigrams. N-grams, sorry, n-gram is the correct spelling. Now we'll wait a bit more. Maybe it's not good that I'm rewriting the same model. Let's rerun model 2, let it be. And so now we'll be building n-grams on the fly. So it's actually saying that it's generating 2 grams for all namespaces. So namespaces, we can actually group features into different namespaces with vertical bars. While it's training, I'll command this Vowpal Wabbit format. So it's from our article. Let's see it. Take a look here. So with vertical pipes, you can actually select different namespaces, and here this subject and organization are actually different namespaces. So a good hash function actually outputs some indices, some hashes, which are evenly distributed. And with these namespaces, Vowpal Wabbit will do even better hashing within namespaces. So there will be more collision in between namespaces, but within one namespace, the probability of collision will be less. So, but in practice, it's it's good to create different namespaces for different types of features, for different sources of features, or different, let's say you've got categorical and numeric features, you'll have a separate namespace for categorical variables and a separate namespace for numeric features. So it's handy to use it. Okay, so you see it actually took 1 minute 20 seconds to train the model with bigrams, and now let's just repeat these steps. It's good that actually the code for predictions is not going to change at all. So we just pass the same parameters, but we grab the second model and let's call it also a different prediction file. Now it will also take a bit longer because now it also generates these 2 grams for all of our words, and this takes a while. And it also means that this model is now larger. It needs to store some cache file, some index with these n-grams. Okay, so I'll for now copy paste the same code. Well, not all of it. Right. Okay, so it took 50 seconds to make a prediction, and now we see that accuracy shall go higher. Okay, so it's now it's 91%, and for now let's stop here, increasing accuracy. So a bit more can be squeezed with these hyperparameters: learning rate, initial t, and power t. So these govern actually the training process, the optimization algorithm. Vowpal Wabbit doesn't provide a really convenient hyperparameter search, but there are some bindings with hyperopt. So there's some guy who wrote a wrapper for hyperopt with Vowpal Wabbit. But in practice, the whole idea here is that we can grab a really large dataset, and we can have a really decent baseline, you see, in just a couple of minutes. So here we're not going to play with all these hyperparameters, but a lot more can be squeezed with, first of all, with learning rate and these hyperparameters governing the training process. Accuracy will go up if you reserve more RAM for hash space. But here you need to be careful, so at some point your machine can hang. So somewhere in between 29 and 30, I guess, well, then your model will actually be consuming some 16 gigabytes of RAM, well, depending on the dataset, of course. And one more improvement is that you can actually do several epochs. So it will be, I will comment it here, but it will be the argument passes. So you can do several passes over the dataset, several epochs. What I forgot here is, of course, reproducibility. So it's argument random seed. As usual for me, it will be 17. And you can actually make the Vowpal Wabbit shut up with flag quiet. Then, okay, I'm not going to launch this, but that's some more flags that you typically use. All right, so a bit increasing this number of bits, so hash space, and playing around a bit with hyperparameters, you can achieve 94 here. So it's pretty impressive, especially if you train the model so fast. Okay, and now I'll show the Python wrapper, which well, you see this utility is very fast, but remembering all these flags is not really convenient. So now I'm going to show Python interface and some, yeah, a bit annoying that here I will have to relaunch Jupyter. So just wait a bit. I guess, yeah, you currently don't see my terminal, but I'm actually launching Docker container, just following the instructions outlined in prerequisites. Okay. Wait a bit. Okay, now my port has changed, 45, 45. Okay, and I've got it here in Docker. Okay, what I actually launched was this command. I'll comment it, but it's actually following the instructions here in prerequisites. So we provide you a Docker image, and we provide you a simple shell script to launch this image. And now, well, I guess Docker version is a bit older here. Yeah, it's 8.5. And there it was, locally it was 8.7, but it's not going to affect too much. But now here I've got Python wrapper. So from Vowpal Wabbit, I will use pyvw. This will be our wrapper. Sorry, from Vowpal Wabbit import pyvw. Okay, and I will reread some of the variables here. Okay, and now actually, so here we'll go Python wrapper. Okay, now we've got this pyvw. We'll have this this Python model vw, and actually it accepts the same arguments as this console util. So you see, it says that it's a trivial wrapper around native Python Vowpal Wabbit wrapper, but actually you just pass the same parameters here. So let's say we'll have the same 18 bits. Let me take a sneak peek to my cheat sheet. I will just reuse the same parameters here. Okay, nothing interesting here. Okay, so we'll only tell that it's 10 class classification, and yeah, we'll make it shut up. So we know that the model trains pretty fast, and the output will be some model. Okay, and so here with this wrapper, with minimal syntax, I will actually be training the model just while reading the data. So it's also covered in one of tutorials that I wrote. I guess it's all the links are here in the bottom. Okay, so we'll literally be doing training while reading data. So it sounds pretty impressive, right? So you just process your data, but you can actually train the model at the same time. Okay, so this, yeah, sorry for the picture, but this for one of Kaggle competitions. The Kaggle competition was not really successful, and it's not about text data here. So you can, in this kernel, you can take a look how you actually process numeric features as well. But we'll reuse a very simple Python interface. So just while reading data, so we'll open training file. So it's our path to data. Let's recall what we had here. Path to data and all of our VW files. Okay, now we have some models there, but okay. So we'll open this file and iterating over the lines in this file. It might be a bit boring, so it's good to use tqdm to track progress. So we'll import tqdm notebook. And so iterating through this file, we'll be just learning the model. And it's as easy as this VW model that we initiated, .learn, and we pass this line. This will be just one line in the format that we covered. It will be a line just like one vertical bar and then question text, just pure text. And Vowpal Wabbit will learn from this line, meaning that it will update parameters. Okay, and now we can track progress here. We can do even better. We know length of all these files, and we can actually know how long we need to wait. I meant VC minus L to calculate the number of lines, and we'll add one more argument to TQDM, total. So currently it's counting the number of lines in training and validation part. So it was something around 2 billion and 2 millions and 1 million. So we'll pass this exact number here, and now we'll know precisely how long we're going to wait. Not precisely, but something around 2 minutes. So now it's actually processing line by line and training the model at the same time, and I will write a similar loop to actually validate the data. So we'll have validation predictions, just a Python list, and we'll change it. So we'll have validation file here. Let's just hard code the number of lines in it. And now what actually changes is just one thing. We'll just call predict. And it will output some just integer, current prediction, let's call it, and we'll append it to the list. Cool, okay, looks good, so I'll just launch it. And finally, yeah, we'll check accuracy again, just to see whether we've done some reasonable job. So I'll just do the very same stuff. Okay, I need imports, not a big deal. I wish I were able to print faster, but okay, no problem. Metrics, import accuracy score. And then in the end, we'll just calculate accuracy score. And we'll take our predictions from here. You see, command line interface is a bit faster. So with these default parameters, 10 class classification, then 18 bits, we were able to train with command line util in just 28 seconds. Here it took a bit more, so 2 minutes. But we were doing two things at the same time. We were reading data, so processing it in Python and using Python interface. You see, it's a bit slower. I actually also noticed that it's a bit slower in Docker image rather than when your Vowpal Wabbit is installed locally or on a server. Well, I don't think I can comment it really well. But it's something about caching files. It takes a bit longer within Docker image. Okay, but let's wait just a bit, around one minute here, and we'll see whether we've done reasonable job. We'll just calculate accuracy once again. And well, if you can allow it a bit more training, so maybe you've got a nice server and you don't really care too much, you can use this very simple Python interface, and still we are training a model with a lot of data in just a couple of minutes. So it's still really nice. And as you see, the interface is very intuitive. You can take a look how you do multiple passes, so multiple epochs within this interface. I didn't do it, and it's just with this code, it's not 100% clear for me how. With this code, we actually do one pass over the dataset, So in the simplest form, it will be just one parse over your data. But I guess you can figure out if you need it, how you do multiple epochs with the very same interface. Okay, so calculating accuracy takes a bit more time. So let's see what's wrong with our validations, with our predictions. Looks like it shall be fine. Okay, I'm not going to debug it right here, but basically the very same code, so you predict with a line, yeah, what we did here, and you just append to a list. So this shall give you just around the same 88% accuracy, which is also pretty fine. So you see, you've got this flexibility, so you can remember all these weird flags for command line util, or you can use Python interface, which is a bit slower, or you can write actually your own interface, not actually just a small Python method which would launch this command line util with all this flag, and you can give them nice names. There is much more to Vowpal Wabbit, so some more capabilities are covered in this article, Vowpal Wabbit tutorial for the uninitiated, and I really recommend to go through this blog to actually understand hashing trick. That's it for today. Yep. Good luck. You can so if you'd like to, you can have some practice with a demo assignment. If you watch me in 2020, okay. Anyway, all the actual assignments will be here in this page, mlcourse.ai assignments. So it's not listed here right now. It's posted on Slack, but I'll make sure that we also have a demo assignment with Vowpal Wabbit. All right. Good luck.